Well, welcome back to the Azure Podcast. This is episode number 466, being recorded on the 6th of July, 2023, with special guest Linda Sheard. I'm Sujit, and on Teams with me, we have Russell and our special guest Linda. We're going to get to in just a minute to talk about a topic that is very, very on top of mind of everybody today, including our listeners. And so we're going to get to that in just a minute. But before that, we'll cover just a couple of items, or maybe just one item. What do we got in the news items here? Russell, I have one, so I'll cover that. And this is about the upcoming changes to the Docker public repository. So, we all use containers from the Docker repository that are public. You can access them anonymously. And they're going to start putting limits on how frequently you can pull those repositories. So if you kind of rely on that for your CI/CD process or for your development on your computers and your laptops, you're going to have you may have some problems with that. And so what ACR has now introduced in preview is a way to cache some of these public repositories inside of your ACR. And so what you could do is you could just pull down the curated list of repositories, put them in your ACR, and then you reference them directly from the ACR. And this way, you're not going to be subject to those same rate limits, right? I mean, with ACR, it's pretty much pay as you go, but at least you're not going to be blocked from accessing those public repositories. So that's I think, a very important feature. I'm certainly going to have to look at it to see if it impacts some of our own services that we use for the Azure podcast to host at and other places that we use containers. So that's what I have, Russell. I guess that's it for the news. Nothing else that popped up on our radar today. So let's get straight to our special guest and our special topic today, which is on Azure OpenAI, which, of course, everybody is talking about these days. And we figured, hey, we should talk about it too. So, Linda, thanks so much for kind of joining us. I know it was kind of impromptu that Russell got you onto the show, but we're glad you're here to enlighten our listeners a little bit on what this OpenAI is.
Just before you hand over to Linda, I do want to apologise to Linda in public because I've just roped her in very short notice. We kind of agreed to do this talk about OpenAI, and when I was out walking at lunchtime, I was just thinking this might not work unless we rope somebody in that knows quite a bit about OpenAI. So Linda is the most knowledgeable person I know on the subject. So sorry for roping you in short notice, Linda, and thank you very much for agreeing to do it.
Yeah, I think you're underrepresenting yourself. We've been talking to customers together, I think, so we're all rapidly learning in this space. I mean, I have a longer history in AI, but then again, we're in a very different world of AI now, aren't we? So, but before we get into that, let me just introduce myself. So my name is Dr. Linda Sheard. I'm a senior cloud solution architect for data and AI, and I work generally across the public sector, but also beyond that with a specialism in geospatial data and all topics AI.
And I mean, we should say that AI and ML have been topics that have been around in the Azure space for a long time, right? But they seem to have just recently, picked up everybody's interest. What would you think, talking to your customers, Linda, what's been that impetus point? Has it been like the advent of ChatGPT, or has it just been people realizing that AI can really help in their own business use cases? What are you hearing?
I think the key dynamic that's really changed and why we've all felt this kind of takeoff of AI is that with the new types of models, and I say new, these kind of transformer models that underpin our generative AI models that ChatGPT is also based on, the paper that underpins all that came out in 2017. So, that's not news as such. But what has happened on top of that is that it's brought together a bunch of domains that were until then very separate. So the computer vision domain and the language domain, for example. And I think we've seen a tremendous acceleration from the those communities being brought together, working on the same architecture. So that's one factor. And then combining that with the compute that's now available on our wonderful Azure platform that's helping OpenAI develop these models has contributed to the acceleration. And then the last factor that I want to mention now is that because these models are now so much more generally capable, by which I mean that we've moved away from a time where we've had to train very, very specific tasks to be addressed by AI, means that it's just much, much easier to take a model off the shelf and use it. So the conversation has moved much more from how do I use my own data to train my own model to how do I take one of these models and effectively integrate it into applications. And that's just a much more accessible problem. And we've got a whole ecosystem of plugins and a whole community that's kind of looking at that using space rather than the training space. And I think that's a really big shift.
I think that's kind of raises one of the questions that I had, and I think, you know, Sujit's been doing some playing with transcriptions of our podcast episodes over the last few days, and that it's interesting to see how that works. But I guess my question is, when you're building this stuff and you've got this access to this like playground with all the different models and things like that, you get a list of all these different types of model that you can deploy. Where do I start? How do I start learning which ones I should be using for what use case? Because it's just, I don't know, and the results we're having with some of the questions we've been asking haven't been strictly very good. And I think it's down to the way that we've chosen the model or not trained it or what have you. We've just basically shoved a load of data at it and said, go and do this.
Possibly, yeah. So that's interesting. So I think maybe what I should say is when I guess you've used the add your data feature in OpenAI.
You bring your own data preview.
Yeah, that's right.
If you go, yeah.
So one thing that's really important to understand about that is that that's a pattern. We call it the retrieval augmented generation pattern. And what that actually means is you've not added your data to the model itself. And I think this is a really good point to just take one step back and remind ourselves that these models are not malleable as such. So a generative AI model is a static thing that it took an enormous amount of compute over a very long time to get to the state it is. So GPT 3.5, GPT-4, they're very large models. And they are as they are. They don't change as you're interacting with them. So the first thing you might ask yourself is, if I have a multi-turn conversation with them, how does it remember what I said before? Why can I refer to something I asked in my first question? And what does this mean? How can it hold that context? And the only way it holds that context is because actually when we talk to it, we send the conversation history in. So on every interaction, the model receives the history that it needs to know to be able to respond intelligently with that context. So that's the first thing to understand. So where does your data come in? When you're using that feature to add your data, you're actually adding your data to a knowledge store that is we used to talk about this as the bee's knees, but now I want to call it a traditional implementation of a semantic search architecture that you can also get via Azure Cognitive Search. And what that does is it allows you to use language to search your data. So if we forget OpenAI for a minute, what that would do is return you the, I don't know, top X number of most relevant results for your query. And traditionally, we would have had to give you, the user, either the full list, or we would have had to pick one and tell you this is the answer to your question. But now we can provide, just like we can provide our conversation history, we can provide those search results to OpenAI as a context to the conversation that you're now having. And now the really subtle thing that is still fascinating to me is that you can give OpenAI an instruction and tell it, just in words, in language, keep your response to what you're getting from that context that we're giving you. Don't give us your own opinion. And generally, especially GPT-4 will be very good at complying with that. But none of these kind of what we call guardrails or groundings are 100% secure. So sometimes OpenAI will look at the search results and will go, that's not the best answer, and it will try and answer from its own knowledge with quite a lot of confidence, and it might come up with things that you would have never expected.
Yeah, that's well put, Linda. But if I may, like maybe we should just step back a little bit in terms of explaining. And it's good that we've laid out the entire end-to-end experience, right? Which is what you've really done very well. But I want to go back for our listeners and just explain or try to understand what just the fundamental OpenAI service does today, right? If taking away search or anything else, fundamentally OpenAI just allows us to you can give it a block of text, and you can ask questions on that block of text, right? Essentially, it can reason over that text, and that is kind of the fundamental thing that it does. I mean, is that a right way to think about it, just like from a starting perspective? Because there's a lot of buzz about what OpenAI can and cannot do, and I want to make sure we're very clear that the OpenAI service does this, right? It's not like this magic kind of wand.
Oh, it absolutely is a magic wand, Sujit.
I'm glad to hear that.
No, I mean, yeah, it just, like I say, I mean, even having been in AI for a very long time, I'm continually astonished by the kind of things that you can do. And you're right. So the effect of what I described earlier is that you can have a conversation about the context, and you can ask the model to summarize those bits of text, but you can also do much more sophisticated things like ask it to extract certain pieces from that text and return them to you in a table. So there's no sort of programming going on under the hood. It's the model actually understanding what is the concept of a table. And you might have to help it with a few examples of exactly the structure that you're looking for. But especially if you give one or two examples, the technical term is one-shot or few-shot learning, in your prompt, then that's often with these advanced models enough to get the result that you're looking for.
And then, and glad you mentioned that. So that is what you just talked about, giving examples. From what I understand in my learning, is that's like fine-tuning this model, right? You start with a base model of some sort, and then you're trying to kind of give it a few hints or fine-tune that. Is that the way to think about it, or is there like another way that people should think about that one-shot, multi-shot, or providing this? I think you can provide a whole file of responses as well.
Yeah, no, you're exactly right. It's the same concept, just in terms of technically how we refer to it. We refer to fine-tuning as the one where you're giving quite a lot of examples in a file, like you said there. Whereas specifically, if you're passing along one or two examples in your prompt, if you say, take these podcasts and tell me, what kind of Azure services Linda mentioned, give me a table. Then you might have to give a couple of examples of how you return the right answer to that kind of questions. And one shot means you give one example, few shot means you give a few. But generally, if you go from, if you go from 2 examples to 7 examples to 10 examples, you're not really improving that much. So, and really what you're just doing there is you're working on the prompt completion kind of architecture. So the model will see what it's been given before, and it will try to continue that pattern that it's seeing, or what's most statistically likely that should come next. So by giving a few examples, you can influence that. If that doesn't get you to where you, Karak, jump in there if you want. Before we get to actual fine-tuning, which is a bit different.
Yeah, but yeah, so I'm glad you clarified that. So is that saved for future? Like, let's say I'm the one doing that prompt, right? And I provide those samples, and let's say Russell comes in to the same service and does a similar query. Will he gain the advantage of the examples that I provided?
No. So in the one-shot or the few-shot learning, that is completely decoupled from the actual model. So it's completely part of your session. And we have a wonderful podcast from some of your colleagues in on the Microsoft research side, where one of them actually tells a really lovely story that he was doing a lot of research on the behavior of ChatGPT or OpenAI as such, and was having some fairly deep conversations with it. And he said he was so disappointed every morning when his friend didn't remember any of that conversation. He had to start again. So, you know, even our researchers who are really at the forefront of this get kind of taken away by how human this kind of interaction can be. But no, your one-shot or few-shot prompting is only session scoped. So you'd have to build an application layer that sends the same sort of examples in every time to make that a bit more consistent.
That's really just, it's just made something twig in my mind, because I do these GitHub Copilot demos quite often. And when I start from scratch and I'm for it beforehand, I try a few things, and yeah, it does roughly what I'm expecting it to do. And then as I get into it and I'm doing different things, and people are asking me to try different things, it's changing, and I'm like, I really don't know what it's going to do next. But now that you talk about that history of the prompt and it's remembering, that really makes sense in context of when I'm doing something and I hit enter on a line, it's got the context of my code. It will give me something different depending on whether I've already tried something before or not in that session. And that's quite clever, because it's as a programmer, I get into doing something and generally I'm going to focus on doing that repeatable thing for a while, you know, whether it's I don't know, copying variables from one bit to another or something. You want to do it for the whole object, and then you will move on to the next thing. And it does replicate that kind of behavior. And you have to kind of tell it, actually, I don't want to do that anymore. I want to do something different now. And you give it the comments to say, I'm going to. It's very, but now it's kind of making sense. And you've answered a few other things as well, which is really coming clear in my mind, which is great.
I mean, for full disclosure, I don't know how. So the Copilot is essentially an application that Microsoft has implemented with ChatGPT or OpenAI as one of the components. I don't actually know how that's implemented in terms of how often your session is restarted. So, you know, every time that you're, presumably it's a multi-turn conversation, as you say, where there's a bit of history that the application orchestration pushes through. But this is really, really important thing to understand, that if you're looking to build applications yourselves with the OpenAI service, there are a lot of design choices that you can make about how much context you provide on each interaction.
Yeah. And sorry, I know I've taken you away from fine tuning, which is what
no, that's fine. We can come back to that.
the other point was, you know, I'd always envisaged OpenAI, and if you want to pull your own instance in, you want to have it in your subscription, it's like, okay, I'm getting a copy of that model, and then I'm making changes to it to specify. But that's not the case at all, right? You're just choosing a model that everybody's looking at, but you're adding to it and augmenting around it using cognitive services. So
you are actually getting your own deployment.
Oh, you are? Okay.
You can. So when you're fine tuning, so this brings us to fine tuning actually. That the key thing to understand is, yes, so if you're provisioning the OpenAI service, that is provisioned in your instance. But that doesn't change the fact that when you're fine tuning, you're still not changing the model. So far we've talked about prompts where you're giving one shot, few shot context, and nothing else. So if we move on to fine tuning, that's what you do when you have a particular use case, and the few shot example doesn't quite get you there. It doesn't quite kind of adapt to your particular domain. So what you'd have to collect then, or find in your historical data, is prompt completion examples, successful prompt and completion examples, exactly the kind that you would use in a one-shot or few-shot prompt. But instead, you're providing those as separate training data. And you then trigger a one-off process that trains some additional, you can think of it almost as a wrapper that sits on top of the model. So there's some additional layers that are added to the model, and that tweak the output for you depending on that. And one of the interesting things, so this is where I don't have enough insight exactly in how that's implemented in the Azure OpenAI service. But in the general concept, if you do this with smaller LLM models, you can do this kind of thing, you know, manually on your own compute resource if you have enough. And something that can happen there is if your fine tuning is too specific for a very specific task, then it can lead to something called catastrophic forgetting. So you actually make your model so focused on those last layers that you're kind of breaking the remembering under the hood. So sometimes it's a good idea to fine tune on a bunch of different specific tasks for your use case together, and you get better results. So there's some really interesting dynamics that happen there. But just coming back to the practicality, your fine tuning data is, again, purely dedicated to you. It doesn't go anywhere else. It sits in your, it's kept in your subscription and your instance.
Okay, and yeah, thank you. That model underneath, you know, the big model that's taken years to build and costs however many dollars it did to build it. How often does that get retrained, refreshed, updated, or does it not? Is it purely read only?
Yeah, it doesn't get refreshed under the hood. So there will be different versions released. So if you look at the OpenAI service, then you'll have a list of options of things you can deploy. You mentioned earlier there's some embedding models and so on. And so it would be quite explicitly announced that there would be a new version. So I think we are on GPT version 0301 or something, the one that was released on 1st of March. And recently there was a more recent one that is released, and you would quite explicitly choose to make a new deployment and upgrade your application to point to that. And I would expect that you would actually have to really review most of your prompt engineering when you're switching to a new model. So I think that's part of the question in terms of application design, that we're in very early stages about, you know, how do you build in backward compatibility into these things? I think these are all very new topics.
Yeah, that's again, choice of model can impact performance of how quickly you get responses back and what kinds of responses you're going to get. So I guess you've got to factor that in as well. So it might not be that the latest and greatest model is the best one to go for. It might be that that's just happens to be the latest one, and the use case that you've got will be well suited to GPT, you know, 2.0 or whatever it was that was out there a long time ago.
Yeah. And this is another one just to flag, you know, GPT is one of those models that is, because it's so big, it has all this sort of multifaceted skill set. But there are slightly more specific architectures, like some of the embedding models, for example, that are really good at particular tasks, like recognizing entities. So in general, the guidance that I've heard, I haven't put this into practice, but the guidance that I've heard is that if you find that an AI use case works well with GPT-4, it's worth then doing some experiments on whether you can downgrade and kind of become specific about the particular use case that you're trying to address, and essentially save money, save resources, in doing that in a lighter way.
Yeah, that's one of the things that I discovered is that, you know, as you said, there's a lot of models there when you go into the OpenAI studio, and for the chat feature, the prompt and the response or continuation, the thing as they call it, to get that feature, you're going to need one of the models that typically start with the word GPT, right? And I think we're using GPT 3.5 Turbo 16K. Now, I believe there's, as you said, there's other models which have the word embedding in them. And when I was playing around with the transcripts of the podcast, I use that to create the vectors, right, for all of the input data. So taking all of those data and running it through that model for creation of the individual embeddings that could be saved into the vector database, right, which I believe is kind of the next step of what we're trying to do here, because until now, the way we've described it is that all we have is a bunch of text, and we can tell OpenAI to reason over that text by giving it all sorts of hints, prompts, continuations. It can try to learn as it goes along, but it's still got that block of text that we gave it originally. The question is, how do we get that block of text to start with, right? In the idea, that's what our customers want to know, is that I've got, 10,000 records over here somewhere, and I need to search them or kind of ask questions of that of all of that information. And so you need, I think the next evolution of this is you need some sort of a search service. And it could be an API that you already have, I guess, right? A customer may have an API that returns some information based on a query, and you can take that information and pass it to OpenAI and say, hey, answer my question with this data, right? And it'll do the best, I suppose, that it can under those circumstances. So I guess that's the kind of easy way for a customer to take existing data and integrate it to OpenAI. Is that a reasonable way to think about it, or from a starting point?
Yeah, I'm glad you've brought up the vector search side of things, because I suppose So the vectorization of language is a really core component of how OpenAI works. And before I waffle on for too long about that, I'll come back to that. If you're using the embedding models, you are essentially more directly using just that component. And so it's a way of converting language into a numeric representation that captures meaning. And then you can do, without OpenAI, some very simple matching of your question and the numeric representation of your question and the numeric representation of all your data that you have vectorized in that way, and find matches by something called cosine similarity. So there's particular databases, particular libraries that help you with that. So if your goal is just to find a good match to your search, it's a really lightweight way of doing that compared to deploying OpenAI. But you're still leveraging that kind of core feature of the very rich representation that we've built OpenAI on top of, which is those embedding. If you've kind of heard models such as BERT, there's many derivatives of BERT, B-E-R-T, Roberta, and so on. They're all derivatives and slightly similar approaches to this problem of vectorization. So, and I think we recently also have a preview in cognitive search that allows you to directly, cognitive search up until now has allowed you to index documents. It now also integrates if you want to take data, vectorize it, and then store those vectors directly and do that kind of vector search, which it sounds like is what you've played with.
That's yeah. So initially I was writing some Python code to do that, to take the some of the transcripts. One of the limitations is of vector of the embeddings is that it only takes I think chunks of data. You can't really give it a big document. I think it's limited to 4K. I think they call them tokens, which I guess is roughly words, right? Although it may not be exactly that.
Yeah, about 3/4 of a word or so.
Yeah, exactly.
Yeah.
So if you have you have to kind of chunk your input, whatever input you have, into that size, and then embed it, create the embeddings, and then you can pass those embeddings onto Azure Cognitive Search feature to store them as vectors. And as you said, the advantage here is that when you do query, it'll now take the vectors that of your query, and it'll be able to find a much more meaningful match for the documents that you want. Now, is that the same as the semantic search feature? Because I also enable that in Azure Cognitive Search too. Is that are they both related? Like, is semantic search just by default a vector database?
Gosh, that's a really good question. I'm not actually sure about all the details of how semantic search is on the API side of cognitive search, isn't it? So we have
in the cognitive search, when you create the service, you just have to enable that feature. I chose the free plan, which is 1,000 queries, 1,000 searches per month. But apparently, when you do that, that's all you have to do, and then the API will start returning different responses, right? Your search API will now return the responses that are ordered in semantic importance, right? Based on the question that you ask. It's not just blindly looking at the words that you entered. It's actually understanding the intent of what you asked for and returning the records in the correct sequence.
Yeah, I mean, that's definitely based on a whole number of natural language processing of the generation before generative AI. I am certain that it will be using embeddings because exactly as you described, it's a context aware of the use of a word. So if I talk about a bow, it will know whether it's related to a tree or a ship, depending on what else is going on in that sentence, as one example. But what I don't know is I don't think it is a vector similarity search where we actually do the matching on a numerical basis as opposed to, basically, semantic natural language processing. So there's a bit of stuff under the hood there that I don't know the right answer, so I'll refrain.
From what I read, it looks like the cognitive search now supports it is a vector database. So
No, it
I'm
does,
assuming
yeah.
that So I'm using that when you do the query, it is doing it at least on that using the vector cosine. I don't know if it does cosine similarity,
Yeah.
maybe using a different
Oh,
kind
no,
of
absolutely.
similarity.
Yeah. So that's the new feature. So the new feature is the vector search preview, I think.
Okay.
The semantic search has been around for a bit longer. So
Okay, so that's kind
many
of a
generations
overlaid on
on top
top of
of each
that.
other. Yeah.
Got it. Yeah. So that's what I did in the podcast transcripts. So interestingly, how OpenAI featured in very often in the whole pipeline, right from the first just transcribing all the MP3s. So just our recording today, we generally publish all the MP3s on our Azure podcast. So I wrote a Python app to take the MP3s and to use the Whisper model also from OpenAI, but you run that locally on my computer. Luckily, I have a gaming computer over here, which is 8 core, because it took.
Oh, Sujit, this is where I'm supposed to tell you that you can download it from Azure ML. You're just setting me up for that, aren't you?
Well, it took me 3.5 days to transcribe all the episodes on my gaming computer.
Wow,
It ran at
cool.
99% CPU for 3.5 days, right? So this Python application just enumerated all the MP3s and kind of converted them into transcripts. Sorry, you were going to. I'll give you the floor to continue what you were going to say about Azure ML.
No, that's super interesting. I mean, I love what you're talking about there because it really brings it home to listeners as well that it's not this one intelligent AI that you now use for everything, but you have to be quite creative and you have to still use your development skills to figure out how do I best use this component to achieve this particular thing, right?
Exactly. Yeah. And, getting the transcripts and, this is some of the, I guess where you can combine different types of data, right? When you're doing queries. So, they talk about how video and the what's said in the video can be combined together. So when I'm find something, it can point me to exactly the point in the place in the MP3 or the place in the video where that is said, right? So that kind of connection is the next level up. But that's the promise of this technology, especially with vectors, is that we can search across all these media formats. So we were all talking about text here, but I think you mentioned earlier how now even video can also be part of that search, and it's essentially the vectorization of all this data that is making it possible, right? Because when it's all numbers, it's all easy for the computer to kind of figure out exactly where you should be looking.
Yeah, this is actually one of the crux of these transformers that I mentioned it earlier, right? That text is coming together with imagery, and the best way to think about that is just to say that if you think about an image, we used to have convolutional neural networks that used to look at what surrounds a particular pixel to kind of get a sense of image context. And what transformers have allowed you to do is to take an image and basically just create chunks of it and line them up. So you scan across the top, you go around next line, scan along, and then essentially you end up with a long sequence of image chunks. And that's a sequence the same as a text is a sequence. But now you might say, yeah, but the text is kind of lined up as it should be, whereas the image sequence is totally scrambled now because I've got one piece of the image about 20 blocks away from where it would otherwise be next to, if you sort of imagine a scan across the image. And this is the magic of the transformers, that the model can learn relationships of what's important that are quite far away in terms of sequence. And this is why this paper was called "Attention is all you need," because the model can discover that actually for this word is here, what's actually important is really long range pattern in this text because it's actually a news article, and that's why they use these kinds of words here. And that's why it also works in images, because that block 1 and that block 20 are actually really closely related, even though they're now really far away from each other, but they, in information terms, they come from the same corner of the image.
Right.
So the model is able to still work with that. So you've hit exactly on the magic of why transformers are so powerful.
That's very insightful. Yeah. Yeah, so so we did that first step, right, of transcribing all these with using the Whisper models, and there were a few models I had to play around with. I used a small model. I think they have various models even in Whisper, which gave me good performance. Now I have 460 text files, right, which I uploaded to blob storage. And then the next step is to take those text files and run the embedding model on them and store them, all the generated vectors, into a vector database, right? So that's kind of, I started doing that with Python, but maybe when I first started this process about a few weeks ago. And then right in the middle, Azure OpenAI announced this service where you can import your data, you can bring in your data directly. Basically, does everything that I was struggling to do in Python
Oh my goodness,
code.
that's happening all the
So
time. It's
just
hard to
like I
keep
was
up.
like, oh, I don't need to write code anymore. Just point to the thing. It did exactly what I was trying to do in Python code, which is took the whole data, broke it up into chunks, ran the embedding, stored the thing into the vector database, and that was it, right? I didn't have to do anything. That was kind of interesting. It took our 450 base records and created approximately 3,800 embedded records, I should say. I don't know if that's the correct term, but yeah.
Amazing. Yeah, I mean that's happening all the time. You were saying earlier you downloaded the Whisper model. We recently had announced the Azure ML model catalog. So this is the interesting thing now. As you know, OpenAI is still sometimes a bit region limited depending on which kind of models you want to work with. But so much of this is flowing into some of the other services. So the OpenAI Whisper you can deploy with a click onto Azure ML Compute. So you don't have to take up your gaming laptop for days anymore. And then over the top of that, the kind of orchestration. So all of that orchestration of many different steps is also something where there's more and more tooling that is becoming available. So yeah, more stuff for us all to learn.
I must say that the one area I'm hoping they would improve on in this process is that it doesn't seem to be a way to update the data feed, right? So I've given it my feed of 460 records, and it's static to 460 records. I can't, like, now we're going to add a new episode today, but there isn't any way for me to say, hey, here's another document, right? I literally have to add the document, delete the previous index, and create a brand new one with the overall, which I'm hoping that there is essentially they're not creating an indexer in Azure Cognitive Search, right? Azure Cognitive Search has this concept of indexers, where then that's what they're for. They can update the index periodically. But when OpenAI creates this index into Azure Cognitive Search, it doesn't create a corresponding indexer. It's just a one-time index that it creates, because it's a specialized embedding index. I think that's why.
It may just be the preview period. I suspect that's something that's coming.
I'm hoping.
Or I think otherwise you can also have your own cognitive service instance and plug it onto that. So in your case, actually, I think that would make a lot of sense, where you just create your own cognitive services instance. And when you hit the button to add your data, rather than create a new one, you select your existing one. And then you can manage that in the same way that we've managed our cognitive search instances before, so which has an API to reindex. So I think in that sense that's already possible.
All right, that sounds good. I'll have to look into that.
Next time, Sujit, you should ask Kale if you can borrow his bit mining rigs. I'm sure he's got some some serious compute for all that stuff that he does on that side of things.
So yeah, I just want to say one thing though. I did try the transcriptions first. I tried to run them. So Azure Cognitive Speech Service, right, which has been around for a while, has got transcriptions facility. So my first started transcribing it that way, right? I said, oh yeah, I don't have to do anything. I just wrote a program to submit all the transcriptions, and it was doing it. But after about 100, about 50 or so transcriptions, it had some sort of error. I didn't remember what, but I couldn't figure out why there was an error. It turned out that it had already cost me $450 to transcribe those documents. I think I was running out of budget, which is why it stopped on my subscription. So that's when I realized, oh, this running this compute in Azure is convenient, but it's also expensive, right? And then I said, okay, I've got the gaming laptop here, so let me run it there. It took 3.5 days, yes, but you know.
That's one of the things that surprised me around when I've been playing with the OpenAI stuff. It's actually been very, very cheap, but I am just using the basic stuff. So I'm not adding loads of indexes and stuff to it. I'm just basically deploying the models that are there and just calling, using the API to ask it, send it prompts basically and do stuff. And that doesn't seem to cost very much at all. So that was a bit of a surprise, because I thought setting up my own instance was going to be, involving lots of data, lots of compute and all the rest of it, but doesn't seem to be.
I will say, I mean, just in all, we like to be open about costs over here on the show, and in using the Azure Cognitive Services feature for the semantic search, like I said, I chose the default, which is a free plan, which gives you about 1,000. The next step up is $500. So there's it will cost quite a bit if you do decide to use this more for a streamlined production service. But yeah, I mean, there's nothing in between. It's 0 or 500. So
again, it depends what your use case is, isn't it? And that's the interesting thing, that the GPT models, because they're so general, you could just use it as a calculator or something, right? It can do the very simplest of tasks, but you've got to just make sure that you're applying the right technology in the right space. And I think that's the challenge that we've got, is to try and make sure our customers are doing the right kind of thing, identifying the right scenarios. So, Linda, I know you've been putting up with me joining some of your sessions where you've been trying to educate our customers a little bit, and I kind of assumed to start with AI 900 as the learning path for this, but you don't seem to think that's the best way to go, and I think the tools have moved on and so on. So just for somebody that's I've been a developer for my whole career, I just want to learn more about OpenAI, how to use it, how AI works a little bit, how to use it in anger. Where should I start?
Actually, AI 900 is certainly, I don't want to be disparaging about. It's a really good foundation course that looks broadly across the capabilities that we have. And one of the modules is also an introduction to the OpenAI service, so what we've been talking about today. And that's also fully up to date and really great. I think the one part where I was a little bit cautious is that within the AI 900, sorry, the introductory model to the Azure machine learning service is very much focused at just the kind of low code features of Azure machine learning. And that really doesn't, in my mind, keep up with what we need these days anymore. We've moved on to a really powerful platform within Azure ML for code first development of machine learning models. And increasingly, that also supports generative AI workflows. There is something called Azure Machine Learning Prompt Flow, which helps you with some of the orchestration that Sujit was talking about. You want to do many things, you want to chain together various processes, and it gives you those kind of capabilities. So for that, I don't think there's an MS Learn module just yet. That's pretty new, but there's a nice build session that maybe we can dig out and supply to folks on this. So yeah, that was my caveat on the 900, I think.
Great. So I'm glad I understand it now. Thank you. Yeah, it's I think using the code first approach is something that I'm more familiar with as well, and that fits in with kind of the right approach around governance and how to put stuff through source control repos, make it reproducible, redeployable, and maintainable. So that's all good. And I can use GitHub Copilot with it as well. So that's
yeah.
Good. I can't live without that anymore.
Nice. Yeah, I mean, so for folks who want to get into the data pipelining capabilities, so we said earlier that the biggest shift, or one of the big shifts with this new AI, is that we're moving from having to train AI to having to use AI, right? And so some of the challenges then come exactly like what you were describing there, Sujit, that you can get hold of a model relatively easy, you can deploy that model relatively easily, so it's available with an API, you can call it. But now you've got a new challenge of how do you create the data pipelines to get your big data to that model at the right rate and with the right sort of scalability. So that's where Azure machine learning pipelines are really powerful, because you can basically set up compute pipelines that can target the right kind of compute in different steps of the pipeline. So you might have a step that benefits from running across a load of small CPU machines, and then the next step needs a couple of big GPUs, and those are the things that you can orchestrate really nicely. And the DP100 course is probably the best one to get into that topic.
Great, thank you.
That's amazing. Thank you. Yeah, and we'll put all these links in the show notes, of course, so our listeners will have them handy. No, that's great, Russell. Any more thoughts for Linda before we wrap up here? I'm
just curious if any of the other oddities that you've encountered. You sort of hinted at that I've explained a lot of things in your mind, Russell, but I'm curious of what sort of fun things you've encountered in talking to OpenAI.
Well, it's the things I've had that have been strange have just been since playing with Sujit's implementation of OpenAI, to be fair. So I'm blaming,
it's just Sujit.
I'm blaming the
it's just my dumb implementation.
I'm blaming the playground piece. Yeah.
And I chose the option of not limiting it only to data. You know, as you said, that's an option, right? Where you can say limit your responses to only my data. And I didn't choose that option. So I gave it the flexibility of augmenting the data because we do have a public website, we do have a feed over there. So, you know, and I think it was doing a good job of augmenting with public available information, which is a nice thing, you know, because I mean, the data that we have is not public in any way, right? We're not too concerned about it, but it's nice how it will take the data that we provided and it will take well-known sources on the internet. It referenced our podcast website very frequently in responses, you know, so it does a good job, but just combining what's on it's like augmenting what's on the internet with your own data, you know, or vice versa.
Yeah, I think you're right. I think there's, you know, I think it's important to be conscious that you can never 100% protect against, even if you specify only use data that we're talking about, you can't protect around the model making different choices. We didn't really talk about temperature, which is a factor that can also affect that you don't get the same response every time that you ask the same question. I think the most important thing about all of this is that if you're building anything that uses OpenAI under the hood, is that you're really transparent with your end users of what's happening here. What is this like? What can go wrong? And just set the right expectations of how people should consume the content that you're presenting them with, and not try to pretend that it's a human. I don't know why we do that. I think we do that because over a long time, we've learned that humans are generally useful to us as an assistant, whereas machines are really annoying, you know, for help on this, press 3. But I think we should learn now that machines can be quite useful. So we might as well be transparent about the fact that they are machines and they're not humans.
Yep. I think the implementation of chatbots over the last few years before this new version's come along has done more damage than good.
Yeah.
For the reputation of robots.
I think you're right.
Yep.
That's been really interesting. Thank you very much, Linda, and thanks for joining on short notice, as I say.
Thanks so much. Yeah, please
feel free
to share
share
any information with us that you think will be of interest to our listeners. We'll be happy to put them along with the show notes.
Yeah, of course. It's been a pleasure.
Thank you.